हेलो बच्चों, कैसे हैं आप सब लोग। आई होप यू ऑल आर डूइंग वेल एंड यू ऑल आर डूइंग प्रिपरेशन फॉर योर एग्जाम्स। आज आप सोच रहे होंगे कि सर ये क्या खेल खेल रहे हैं, खेल खिला रहे हैं क्या। नहीं, ऐसा नहीं है। अभी आपने देखा कि जैसे ही मैं इस आर्टिफिशियल एप्पल को छोड़ता हूँ ये नीचे गिरता है बराबर। ये कभी भी ऊपर नहीं चला जाता, ऊपर नहीं जाता, बल्कि हमेशा नीचे गिरता है। बेटा ऐसा ही प्रश्न आइजैक न्यूटन के दिमाग में भी आया था जब वो एक एप्पल ट्री के नीचे बैठे थे और एक एप्पल ऊपर से टूट कर गिरा, उनके सर पर गिरा एंड ही स्टार्ट टू थिंकिंग कि भाई ये एप्पल नीचे ही क्यों आया, ये ऊपर क्यों नहीं चला गया। वहीं से स्टार्ट हुआ कॉन्सेप्ट ग्रेविटी का और कॉन्सेप्ट ऑफ ग्रेविटेशन। आज हम लोग इसी पर बात करने वाले हैं, इसी पर डिस्कशन करने वाले हैं। तो आज का हमारा टॉपिक है ग्रेविटेशन। ठीक है, क्या है ग्रेविटेशन, क्या है ग्रेविटी। बहुत सिंपल सा आसान सा कॉन्सेप्ट है कि हमारी जो अर्थ है इसमें एक यूनिक प्रॉपर्टी है, इसमें एक गुण है जिस कारण से ये हमारा हर ऑब्जेक्ट को अपनी तरफ पुल करती है। इट अट्रैक्ट्स एवरी ऑब्जेक्ट टुवर्ड्स इटसेल्फ, राइट। This property is simply known as gravity. So the property of the earth to pull any object towards its center, this is simply known as gravity. And due to this property, gravity, a force is exerted by the earth on any massive object. That is known as gravitational force. The force exerted by the earth on any object is known as gravitational force. And this unique property of earth is simply known as gravity. Got it? This concept is clear, this term is clear. What is gravity, right? Okay, what is gravitational force? Now, as we know that the force is a vector quantity, it has magnitude as well as direction. So we must know about the magnitude of the gravitational force which our earth exert on any other body, and we also come to know about the direction of the gravitational force. So before discussing about direction, the first of all we will discuss the Newton's law of gravitation, which gives us about the magnitude of gravitational force which our earth exert on any object. Okay, so this gravitational force is simple, depends on the following two factors. The first factor is the masses of the two bodies on in between the gravitational force is acting. Their masses are, suppose these are the two bodies having the masses m1 and m2, which are placed at a distance d from each other in the universe, anywhere in the universe, right? M1 and M2 are the masses of the two bodies which are placed at a distance d from each other in whole universe, anywhere, right? This law is applicable in whole the universe. That's why it is also known as universal law of gravitation. What is the name is given? Universal law of gravitation. Got it? So what the law says, there are two statements of the laws. First listen the statement, then we'll discuss, then we'll write down its mathematical expression also. The first statement is the gravitational force is directly proportional to the product of masses of the two bodies. Got it? So first statement is gravitational force is directly proportional to the product of masses of the two bodies, right? F proportional to m1 m2. The second statement is the gravitational force is inversely proportional to the square of distance between them. Got it? The gravitational force is inversely proportional to the square of distance between them. These are two statements. The first one regarding masses of the body and second one is the distance between the two bodies. When we combine these two statements, what we got? We got F proportional to m1 m2 divided by d square. This relation we'll get when we combine the first and second relation, F proportional to m1 m2 upon d square. What will be the next step? As we all know, whenever the sign of proportionality changes, it always gives the sign of equal to and some new constant always there. Here once again we have the new constant. A constant is there which is known as universal gravitational constant and represented by G. G is universal gravitational constant. It's a constant, right? So here we got a formula for finding the magnitude of the gravitational force acting between the two bodies which are placed anywhere in the universe at a distance d. The formula is F is equal to G m1 m2 divided by d square. The formula is clear? Okay. Let us talk about the G. As I told you, the G is universal gravitational constant and its numerical value is 6.67 10 is power minus 11. Do remember. You must remember this value. Numerical value of G is 6.67 10 is power minus 11. What will be the unit? What is the unit of G? We can easily calculate the unit of G from the formula. From formula, if we find out the value of G, then it comes F into D square divided by M1 M2. And from this relation, we can easily find out the unit of capital G, which is known as universal gravitational constant. Like put the units of the other physical quantity. F is Newton, D is the distance, its unit is meter square, mass unit is kg, kg into kg. So the unit of G becomes Newton meter square per kg square. Newton meter square per kg square. This is the unit of capital G, universal gravitational constant. Okay, so this relation is clear to all of you. The law of gravitation is clear to all of you. The law simply says whenever two bodies of masses m1 and m2 are placed in universe anywhere, a force acts between them. That force is known as gravitational force, and this force is directly proportional to the product of masses of the two bodies and inversely proportional to the square of distance between them. When we combine these two statements, we will get the final formula for gravitational force acting between two bodies. The formula is F is equal to G m1 m2 divided by d square, where m1 and m2 are the masses of the body as shown in the diagram, and d is the distance between them, and capital G is a universal gravitational constant. Is that clear up to here? If any doubt, you can ask me. Okay, till then, keep reminding. All the best to all of you. Thank you.